Hi all, welcome to our next video on measures of variation. In this video we're going to talk about something called the variance. And it turns out the variance is related to what in our last video. In other words, the variance is the thing under the square root in the standard deviation formula. And we're going to use this relationship to write the symbol for it. The symbol for variance is the symbol for standard deviation squared. And we get one for sample data and one for population data, just like we did for standard deviation. So for sample variance, it's x squared. For population variance, it's sigma squared. Fraction, because it's an averaging process. In both cases, we are looking at sum of the deviation from the mean squared. We know for this when we average, it's n minus 1, whereas with the population, it's the population size, capital N. I'm going to scroll up to our example from our last video because it turns out that we calculate this as part of calculating this. So if I scroll back up to our notes from standard deviation, we did an example where we found the standard deviation of this data set. We made a table with the data values, our deviations, data minus means, the square of the deviations, data minus mean squared, and then we added those numbers up. And that gave us the top of this fraction. That's this value here. And then you can see when we did the standard deviation calculation, it was that sum on top and n minus 1 on bottom, which gave us this number here. So this number here is our variance. The variance is the next to last step in a standard deviation calculation. We can double check this relationship. We know our standard deviation was 5.9. So our variance, Sx squared, should be 5.9 squared. And if I do that on a calculator, 5.9 times 5.9, oops, I guess it helps if I type 5.9 both times. I get 34.81. If I go back to our notes and we look at what we had before, we had a 34.9. Did I do a boo-boo? No, I didn't. So the question is, why do I have a difference? And the answer, most likely, when this happens, because we had 34.81, is that one of these values was rounded by our calculator. And my calculator, I suspect, is rounding everything to one decimal place, and that's why this number doesn't quite agree with 5.9 squared. They're close. If I round up, they both round to 35. So 2 ways to get variance. We pick it up as an artifact during our standard deviation calculation. Or if you've calculated your standard deviation Sx using one of our stats on your calculator, take that number and then square it. And that will give you variance. All right, if you have questions on the variance, feel free to send me an email. Otherwise, I will see you in our next video.